Okay, this is graphing sine and cosine remediation notes. This is to help get you ready for the final reassessment. And this is a page of notes with the highlights. We're going to breeze through and hit the most important things. Okay, the parent graph of sine is given here. This is y equals sine of x. The things to notice about sine are the fact that there are 3 points on the midline within each cycle. Sine starts at the origin. If I go to fill in my table over here, at 0, sine is 0. At pi over 2, it's 1. Pi is back to 0. 3 pi over 2, it's -1. And at pi, at 2 pi, it is back to 0. So this is the basic parent graph, the sine curve, parent graph of sine of x. The transformational form looks like this. It's the same transformational form that's used for every type of parent graph that we've seen in the last 2 years, basically. The most important thing to point out here is when you're looking for the period based on the equation, you're going to use this little formula here, 2 pi over b. So you're going to pay attention to the value, whatever number is there. If there's not a number there in front of x, then we know it's an understood 1. And so whatever number I have in that position of my equation, I'm going to put into this formula down here, which is 2 pi over b. The reason for that is because the standard period for sine as well as for cosine, the standard period is 2 pi. So otherwise, in my transformational form, this number here that comes in front of the sine, sin, is the amplitude. Amplitude is always positive. Doesn't matter what value is in the A position, the amplitude is always positive. The phase shift comes from this spot, and because of this negative sign, it's always the opposite. So you say it's either going to go to the left or to the right. And then D, the D position tells me my vertical shift. So it's going to go up or down based on whatever number is in that spot. This exact same transformational form is used for cosine. And you'll see here on the notes page, it's exactly the same. Oops, looks like that's a little typo right there. That should say cosine. But it also is the same form for tangent. Now, the period here, standard period for cosine is 2 pi. That's the same. The midline is at the same location for the parent graph. This is my midline. But the difference is sine and cosine have a different starting point for their parent graph, and they have a different number of points on the midline in the parent graph. Cosine only has 2 points on the midline in its parent graph. And to fill in the table, cosine starts at 0, 1. This starting point is 0, 1. So that's important to note because sine starts at the origin and cosine does not start at the origin. Cosine starts up here at the point 0, 1. So then I can fill in my table of values. I can also get this information from the table in the calculator. Excuse me, that should be +1. Okay, so same exact transformational form. If I want to find the period, I put it into the formula 2 pi over b. Now that one piece of information there is very important because it changes when I go to look at tangent. So just because it's already on this notes page, let's pay attention here. Tangent. Since tangent has a standard period of pi, and that goes for tangent and cotangent, then my formula has now been changed to pi over b. So I still look in the same spot for the value of b. Whatever number I find here in this location of my equation, I'm going to put that into my formula in order to find out the period for tangent. Some other important things about tangent: it has the same location for the midline in its parent graph, but it only has one point on the midline in each cycle because tangent is so very different. Tangent and cotangent do not have an amplitude. Okay, it looks like we've got another major typo here. This needs to be corrected. There is no amplitude for tangent and cotangent. No amplitude. There's none whatsoever. There's no amplitude because there's no maximum or minimum. These graphs extend infinitely in either direction when it comes to the range. So there's no maximum point or minimum point. So there's no amplitude. And that goes the same for cotangent as well. Okay, so using these pieces of information, using these basic notes, we're going to go over to the graphing sine and cosine practice sheet and take a look at some graphing questions. Okay, our first question here asks us to choose the correct set of key attributes for this trig graph. They've given me a picture of a graph. In order to find the amplitude, you want to first count to see how many units, the distance between the maximum point of your height, the highest level, the highest point of your graph, and then the lowest. So it looks like our highest is up at 6 on the y-axis. The lowest is down here at 2. So that means this distance is a total of 4 units. Now I'm going to cut that in half in order to get my midline. So when I cut that in half right here, I can draw in my midline. Here's the midline. This would be, the high line or the low line. But the midline is what's really important to me. That helps me find my amplitude. The amplitude's the distance between the maximum point and the midline. So this distance tells me that the amplitude is going to be 2, and it's the same distance as it is from the lowest point to the midline. The lowest point to the midline is also 2, positive 2, amplitude of 2, so I can go ahead and cross out this option. I know that's not going to be a possibility for me. Now, this particular graph looks like it could be a cosine graph, and the midline is going to tell us how many units it has shifted up. Obviously, this has shifted up, and the midline for my parent graph is at the origin. So when my parent graph starts out, my midline is here. Remember how we marked that on the notes? And so since I started here and now my midline is up here, I can count to see how many units I have shifted up. So now I can see I've shifted up 1, there we go, 1, 2, 3, 4. It's shifted up 4 units from where the parent graph is located. So up 4 units. It looks like that's the only option I have. So I've got an amplitude of 2, vertical shift up 4. Let's check the period just to make sure. The period we get from the beginning point. So let's say this is my beginning point, and then the ending point would be where it's going to start all over again. So the beginning and ending are basically at the same spot, the same y value. So the distance from the beginning of the cycle to the end of the cycle is your period. And in this case, it goes from 0 to 4 pi. So the period is 4 pi. Okay, that gives us D. And let's keep going. Match this graph with the correct equation. The best choice for this is to go to your calculator and type these into your calculator and graph them. If you're working at home and you don't have access to a TI-84, you can go to Desmos and type these in, and it's going to show you exactly what your graph should look like. It looks like to me, since this is starting here and ending here, this would be a graph of sine. This looks like a graph of sine here. And it's going up to 2, so it's going to have an amplitude of 2. The period, it's going from 0 to 4 pi. So it looks like the period's going to be 4 pi. If the period is 4 pi, I have to work backwards to figure out what's the value of b. So I know that my formula is 2 pi over b. And according to my graph, my answer for that little formula should be 4 pi. So I need to figure out what number belongs in the b position so that when I do this fraction division, I'll end up with 4. And so it looks to me like b is going to have to be 1/2. If I put 1/2 in the denominator of that formula, 2 divided by 1/2, or 2 times 2 over 1 would give me 4. So I'm going to have to put 1/2 into the b position. So 1/2 would go here, and then I have x. It doesn't look like it shifted in any way, left or right or up or down. So I believe this is going to be our equation 2 sine 1/2 x. And notice that this looks a little bit different because x over 2 is the same as 1/2 x. Okay, let's draw the midline on this. The midline is right smack in half. You might be able just to eyeball it and take a look and see what looks like about half. I'm thinking at first glance that might be it. So let's check. We've got 1, 2, 3 units below, 1, 2, 3 units above. So I believe that's it. Counting those units helps because that tells me the amplitude. The amplitude is 3 for this graph. Let's see, I'm not sure if we even really need to know that. We drew the midline, check, and now state the range. The range is the set of all the y values. So the lowest value is here at -4. The highest values are up here at +2. So the range goes from -4 to +2. We use the hard brackets to write it in interval notation. And you always put the smallest number on the left side. So the negative numbers always go on the left side. All right, now if I'm given an equation like this and I need to graph it, the first thing I'm going to want to do is fill in my table for the parent graph. So as far as this column goes, this is the column where you fill in the parent graph values, and you can get these from your calculator. You just type in cosine of 0, cosine of pi over 2, and type it in, and it will give you the solution. So at pi, we're down at -1, or maybe you just remember those values from your unit circle. Then the next column, you're going to be putting the new values for your transformed graph, and you're going to get those from your equation. Whenever there are numbers in your equation, remember your parent graph is y equals cosine of x. So any numbers that I see in my equation outside of what my original parent graph is are going to give me the values to use to calculate in order to get my new transformed coordinates, okay? So this 2 here, this 2 right now is being multiplied by the cosine. So that's what I'm going to do to each of my parent graph values. I'm going to multiply each of those by 2. And then I'm also going to use this value down here, subtract 1, and I'm going to subtract 1 from each of my parent graph values in order to get the new value. So let's fill this in. Okay, so now that I have this, I don't need my parent graph values anymore. I'm just going to plot these points, 0, 1. At pi over 2, I'm down at -1. At pi, I'm at -3. 3 pi over 2, I'm at -1. At 2 pi, at +1. And here is my graph. I only have to graph one cycle. So if we want to fill in this part here, the amplitude is 2, the period is 2 pi. We get that from this value here. There's technically a 1 in that spot. It looks like a 0, but it's really 1. And I use the formula 2 pi over b. So I put 2 pi over 1, and that's what gives me my period of 2 pi. The phase shift would be inside the parentheses, and there's not any, so I put none. And the vertical shift is going to be down 1. All right.